Hello everyone. I'm going to discuss about how to find the equation of tangent line and normal line. This you have to remember that tangent line and normal line always creates a 90 degrees angle in the middle. Oh, 90 degrees angle where they intersect with each other. It always creates a 90 degrees. And we have to find their equation. So I'm going to teach you how to find the equation of tangent line and normal line. This is the point where they intersect. First example is this one. Find the equation of the tangent line and the normal line to the parabola. And first, we have to derive this first equation, 2x minus 5. And then we have to substitute the value of x and y. You have to substitute. If you find the derivative, you automatically substitute it, which is -1. And this is our first slope for tangent line, for tangent. And then for the normal line, we just inverse the m1. We find the inverse of -1, which is +1 for normal line. Now that we found the m1 and m2, we are going to use this formula after finding. Substitute the value of this, then cancel. This will become -x plus 2 minus 3. Then y equals -x minus 1. So that's it. That's the answer for tangent. That's the equation of tangent. Hello everyone. I'm here to discuss about angle between two curves. Example is, let's draw two curves, and then this is the first function, and then this is the second
Then after that, let's draw the tangent line of each curve. Then this is the angle 1 and angle 2. Then this is what we need to find. The middle one, we need to find that. Then we are going to use this formula. Here's the example question. First things we need to do is find the value of x and y. Then let's use algebra to find the value of x and y. Let's divide both sides by 8. Then after that, we need to substitute the value of y here. And let's erase that. Then x, let's distribute the x over 8 equals 8. Then multiply both sides by 8 to cancel the 8, which gives us 64. Then let us put this in a cube root to cancel the power of 3. Cancel. Then cube root of 64 is 4. Now that we have the 4, we just simply need to find the y value. Then let's just substitute the 4 to any of the equation. Let's choose the easier one. Then 4y equals 8. Then divide both sides by 4. Y equals 2. Now that we found the value of x and y, we need to derive both equation. We need to derive 8x squared equals 8y this is just explicit. Y prime equals 2x over 8. Then to find the m1, we just need to substitute the value of x and y which gives us 1. Then let's derive the second one. This one, let's derive to find the m2. xy equals 8. Then deriving this gives us y prime plus y equals 0. Then y prime equals negative y over x. Now to find the value of m2, let's just do it again. Substitute the value of x and y. And now we found the value of m1 and m2. After that, we apply the formula, which is tangent theta is equal to absolute value. I forgot to put absolute value. Absolute value of let's just substitute the over 1 plus negative 1 half 1. Then let's calculate it. It's negative 3 halves over 1 half, which equals to 3, since it's in absolute value, tan theta. After that, we will do this arctan theta equals arctan times 3. Then there you have it. I already found the angle, and that's the final answer. Hello everyone, I'm here to discuss about maximum and minimum and how to find the relative minimum or maximum of a function. So here is our first example. Find the relative minimum or maximum of x cubed minus 6 squared plus 1, 6x squared. Remember that if the critical value is positive and negative, this means it is a maximum, relative maximum. Then if it's negative then positive, then it is relative minimum. But if both of them are the same sign, like this, if both of them are in the same sign, then it's none. It can't be maximum or minimum. So let's start. The first thing we need to do is to find the first derivative of a function, which is 3x squared minus 12x. You can see that we can factor out the 3x minus 4, and now we need to equal them to 0 to find the critical value. So for the 3x will just be equal to 0. And then this one, x minus 4, will be x equals 4. And now we have found our critical values. After finding the critical values, we need to find the critical points, which is the x and y. So simply we just substitute the critical value into the function. Just substitute minus 6 0 raised to 2 plus 1. And then put it in a calculator, which is just equal to 1. So this means the value of Ry is equal to 1. And now let's try to find the second one using this. So let's just substitute the value of 4. 4 raised to 2 plus 1. Then let's put it in a calculator to solve it. And the answer is negative 31. So this means the value of Ry is negative 31. So let's put the value of x, which is 4, and the value of y, which is negative 31. After finding the critical points, we need to use the first derivative as a sample. So let's use this one. And then we can choose any number that is more or less than 0. And then substitute it to the x. You can choose any number you want. This is equal to 15. Now, since it is equal to positive, there's a chance that it will be relative maximum or not. So we have to choose any number from the right side or any number that is more than 0. So let's choose 2. Then let's put this in a calculator to solve, which is equal to negative 12. As you can see, the first one is positive and the second one is negative. So this means this is a relative maximum. So this means this is a relative maximum. After that, we need to do the second critical points. We need to do the second critical points also after finding the first one. So just no. Now we need to substitute a value that is less than 4. Any value that is less than 4 will work. Let's choose 3, which is equal to negative 9. So since it's negative 9, there's a chance that it's a relative minimum or it's not. So let's do the second one. Now let's choose any value that is more than 4. So let's choose 5. Just substitute it. And this is equal to 15. It's equal to 15. So as you can see, it's negative and positive. So This means that it's a relative minimum. So we've now found that this is a relative minimum. We can also use the second derivative test to test if it's not. There's other methods. We just need to derive it twice. We need to derive this again. Take note that if the constant is less than 0, then it is maximum. Then if the constant is more than 0, then it is minimum. Now let's derive this, which is 6x minus 12. So this is the second derivative. And now we are going to use the value of x and substitute it. 0 minus 12. And this answers to negative 12. So since it's negative, it's less than 0. So this means that this is a maximum. The first critical point is maximum. And then we also need to do the second one, the second point. And take the value of x and substitute it. Minus 12 is equals 12. And now, since it's more than 0, as you can see, 12 is more than 0. This means that the second critical point is minimum. So this is the final answer. This is the maximum and minimum. The critical points, I mean. So